What happens when a molten ionic compound undergoes electrolysis? We will use molten lead-2 bromide PbBr₂ as our example. By identifying the ions present and following where they move, we can predict the products formed at the electrodes. An ionic compound cannot normally be electrolyzed while it is solid. In the solid state, its positive and negative ions are held in fixed positions within a giant ionic lattice. The ions can vibrate, but they cannot move from place to place and carry electric charge through the compound. When the ionic compound is heated until it melts, the lattice breaks down. The ions become free to move, so the molten compound can conduct electricity and undergo electrolysis. Now, let's follow the ions in molten lead-2 bromide. Lead-2 bromide has the formula PbBr₂. When it is molten, it contains mobile Pb2+ ions and Br- ions. Because the compound is molten rather than dissolved in water, these are the only ions present. There are no additional ions from water to compete for discharge. The positively charged Pb2+ ions move towards the negatively charged cathode. The negatively charged Br- ions move towards the positively charged anode. Let us now examine what happens when these ions reach the electrodes. At the cathode, Pb2+ ions gain electrons. Each Pb2+ ion must gain 2 electrons to become a neutral lead atom. Gaining electrons is reduction. Lead is therefore formed at the cathode. The temperature must be high enough to keep lead-2 bromide molten. At this temperature, the lead produced is also molten and collects near the cathode. At the anode, bromide ions lose electrons. Each Br- ion loses 1 electron, but bromine exists as diatomic Br2 molecules. Therefore, 2 bromide ions are needed. Losing electrons is oxidation. Bromine is therefore formed at the anode and escapes as a reddish-brown gas. For the electrolysis of a molten binary ionic compound, the products are usually straightforward to predict. The positive metal ions move towards the cathode, gain electrons and form the metal. The negative non-metal ions move towards the anode, lose electrons and form the non-metal element. For molten lead-2 bromide, the overall equation is as follows. So remember, the metal forms at the cathode while the non-metal forms at the anode.